I'm JC Jones. I work for Mozilla. I'm part of the security engineering team, and they're working on Firefox. And for about a year and a half, through 2014 and 2015, I actually was one of the principals on Let's Encrypt that brought that out into the world last December. And I got asked to not get too close to that speaker. Sorry. I got asked to come talk about PKI and policy, and just before I get too started, please raise your hand if you understand the web PKI. If I say that. Okay, great, that's fine. To be honest, I often don't understand the bloody web PKI. It's freaking complicated. So let me just then start out by saying, if you have clarifying questions, please feel free to just shout them out. We don't have to be formal here. I do have a period at the end for Q&A and some ideas for things you might want to, or topics. But yeah, if you've got clarifying questions, just feel free to ping. And I did just tweet the link to the slides if you're interested in that sort of thing. So I'd like to start off with a bit of a moment of historic reflection. If you want to think back to 21 years ago. The first version of Netscape got released with HTTPS support. So anybody who was using the internet at the time, probably through AOL or your WinSock client, could do encrypted communication. You didn't have to actually be involved in government stuff, and it was all this asymmetric cryptography that basically nobody knew anything about. And we've been at this for 20 years, and it's not enough HTTPS on the internet after 20 years. If you load a website and it's not encrypted, your privacy and your security are just not maintained. All of you know this, that you can just go, it's not that hard to man in the middle a TCP connection. And today, 40% of page loads are encrypted, and honest to God, that's pretty much all Google. Like a giant percentage of that out of Firefox's telemetry is people loading Google and Facebook. So the internet is just not protecting itself the way it should. We all love the, 5 years ago, Firesheep made this really easy to show your friends that you could steal their login cookies for Facebook and screw with them. I don't know if anyone would have done that. That would be terrible, but I certainly didn't do it to anybody I know. And unless you actually encrypt that connection, people can go steal the data, they can go change the website. You may be familiar with the Verizon super cookie that they've gotten smacked down over. ISPs are, we're all here in the United States, and for the most part, people here play by the rules, but you may not be aware that a lot of ISPs in places like India and China, in order to lower their prices, have taken to replacing various websites' ads with their own, just right on the wire. They just trade out all the ads on the New York Times from American-centric ads to whatever the hell they want. Or some of the more funny ones are places that take, there was one provider, a cell provider in India, who replaced any computer vendor's website with some Indian company that sold computer vendors. So if you went to Dell.com, you got some other local site that would try to sell you shit. This happens, especially in developing markets, a surprising amount. There's another fun thing that just in the recent news aspect of things, to add to Shogo and Alex's list from the beginning. Not only are ISPs doing this, but there's two major telecoms. A paper just came out 2 weeks ago. Two major telecoms in China are changing the shit at the network switches, in the center of the network. They are decrypting some sites where they can, and then injecting, changing Google the Google Analytics to other sites, or they're changing various ad networks JavaScript to other ad networks JavaScript. This is just happening if we don't actually protect our connections. So the question, of course, is, God damn it, IETF, why haven't you fixed this shit yet? Why isn't security the default after 20 years since we've been doing this for 20 years? And the honest truth is that it costs money. And one of the things that really bugs me is, it costing money to set up security on a website is an annoyance here in the United States. It's like, at best, 15 bucks US. There's 750 million websites on the web today. I think that number is from like a month and a half ago. That number just keeps going up as the developing world comes online. We've got another 1 billion people coming online in the next 3 years. And most of them cannot afford 10 US to go encrypt their website. So what are they gonna do? They're gonna triple the size of the friggin' web, and they're not gonna have any security, and we're gonna have an even harder time fixing this shit. So, it costs money. User experience is hard. I've talked to a couple of you tonight who have pointed out that you've tried to get certs in the past, and it's shitty. Why is this so freaking hard? We need something that's free. I remember telling people, it's a year and a half ago when we were pitching this, we need something that's free and easy and open so that nobody has to worry about this shit anymore. We can just solve this and get it out of the way and start talking about bigger problems. And so that's what we did. It's called Let's Encrypt, and we launched it 3 months ago. So thank you. So Let's Encrypt is a free certificate authority. It doesn't matter, whether you have money. It doesn't matter if you're a multi-billionaire or a 12-year-old on an allowance setting up your first website because you think computers are cool and you don't want to have all this shit get screwed up on you. And really doesn't matter if you're an organization or an individual. That's actually also a major problem for a lot of folks developing world. Trying to go get a cert off of GoDaddy, they try to upsell you really hard into getting ones that are organization validated, and you don't have any business. What the hell? Let's Encrypt is also automated. Everything that you do in verifying that you have domain control going on is built on a standard protocol that's there to try to simplify the whole thing into you don't have to think about it. And that works for certificate renewals as well. Okay, when I say certificate renewals, has anyone been bitten in the ass by this? All right, I see some hands. I'm actually surprised. You guys don't do certs on websites much, or are you really good at looking at your calendars? Like, I've gotten bitten by this so many times in my life. Calendars? I just suck. I mean, that's true. Okay, and then I don't know if we have a whole lot of open source and like EFF toting aficionados around here, but oh, excellent. But Let's Encrypt is also a transparent CA, and everything we do, we make as transparent as we have been able to figure out how to do. And every cert that we issue goes into certificate transparency, which is like a blockchain for certificates. So you can review everything that we do. It's not like Komodo that hides all this shit as much as they can. We publish transparency statements saying how many national security letters we have received. Currently that number as published is 0, and if we had gotten one, I couldn't tell you, but I can tell you right now that we haven't gotten one. We're unlikely to get one because we're so transparent. They'll go to someone else, I imagine. The whole certificate authority ecosystem, personally I think it lacks the sunshine that I like to see in things that I'm told I have to trust in order to do things on my computer. And when you get down to it, your browser has 2,000 certificate authorities in it that it has trust in, and how many of them are out there actually telling you what they do every day? Kind of makes me sad. And then for all of you open source aficionados, everything that we do is open source. The software that runs the certificate authority itself, it's a piece of code called Boulder, written in Golang. That's entirely open source. It's actually really freaking stable. I'm quite impressed with it. So all of the service outages you may have heard of for Let's Encrypt, none. Even then, through all of this, yeah, Golang's pretty good stuff. The clients, the official client at let'sencrypt.org, it's written in Python, is also open source. This presentation is open source. It's on GitHub. Feel free to fork it. I probably won't get to your pull requests during the presentation, but maybe in version 2.0. And then Let's Encrypt is also a cooperative CA. We could not do this on our own. 2 years ago, some of my colleagues at Mozilla met with some folks at Acme and Cisco and the Electronic Frontier Foundation. There was a lot of drinks. There was a fair amount of angry ranting. And the argument, uh-oh, here comes the shot, huh?
That's right. That's what I'm doing tonight. I'm sorry I'm late. I had to work. It was terrible. It's still terrible. But I'm here, and some Sat KC is better than no Sat KC. And audiences are better than no audiences. I've got to give a presentation for 2 hours over the phone with no slides. I'm going to be sitting by myself talking to nobody in a conference room soon. It's going to be awful. But of course, audiences aren't going to be here without speakers either. And all of our speakers, of course, if this is your first time, you've got to take a shot. So, to our wonderful audience, please give our speaker a big hand while he takes a shot. Well done. That was tall. That was tall. Good luck.
What's going on now? Where am I?
Now you get to finish your talk.
Oh, shit. All right. Thank you very much. The first 4 of those, we were the founding companies, and it's just a handful of folks at each one of those that all got together and said, we want to do this thing. How can we put this thing together? The internet needs it. The guy that was the editor for the TLS specification, Eric Rescorla, told me back in December, he joined Mozilla to do Let's Encrypt. And to give you an idea, he's been at Mozilla for 6 years. So this is not a short-term project. It's taken an awful lot of time. Like the company that, the not-for-profit that runs Let's Encrypt, the Internet Security Research Group, I know a lot of the press coverage has said that this is all in response to Edward Snowden's revelations that all these companies got together to set this thing up. But it's actually not true. The founding date for the not-for-profit, ISRG, is back before Snowden because it just takes this long to set this sort of thing up. We had a whole lot of challenges to get in well, not in the web browsers, but to get across signature so that we'd be publicly trusted and, get all the money. This stuff takes money. It's all our own. I don't know if you're aware, but none of this is cloud stuff. We had to actually buy stuff, rack and stack it, and put it in data centers. It's good stuff. So, all of these companies have joined us, by the way, which, if you can measure the success of an open project by how many folks you get collaborating together on it, I think we're doing okay. My favorite is that we have like Mozilla and Chrome up there. Makes it kind of hard to, I think the web browsers like it. So, making Let's Encrypt function, with all of this simplicity that we wanted, so that this could all just be automated away and we could get back to securing the more interesting problems of the internet, needed a new language to describe how to set up secure servers. Honestly, most of us are protocol engineers, so we immediately say, we should have a protocol to do this. And that's, of course, what we did. We came up with Acme. We actually had a whole host of names that were Looney Tunes based for all this stuff. All that stuck was Boulder, the name of the CA software, but we had a whole lot of them. But Acme, Automated Certificate Management Environment. The whole point of this is if you've got a website, the normal example.com, in order to be allowed to issue a certificate for that website, the main thing you have to do is prove that whoever's getting that cert really controls the website. That's the crux of what CAs have to do. And traditionally, if you go to whatever your certificate authority is today, that's typically done by sending you an email after you fill out all the weird incantations and web forms, and you click through the, no, I don't actually want the insurance. Why do I want that? No, I don't need web hosting. But the crux of it, the thing that you actually have to do is verify ownership of the domain. So we, being protocol folks, said, okay, let's come up with a series of challenges that we can automate entirely. Because email has, anyone who's tried to set up, automate, like scripted email has probably stabbed themselves in the face at least once. There are better things. So we've got 3 things you can do. They all work pretty easily. You either set up DNS, or you set up a web, like a file on your web server, or you just configure the web server itself. There can be more ways we can do this. We've talked about more. We're open to more. There are things other than TLS servers that can be secured, though right now that's what the focus has been on. And all of this appears in this upcoming standard called Acme. So Acme has been taken to the Internet Engineering Task Force and has a working group. It's also a topic of great conversation at the CA Browser Forum, which is, if you're not familiar, all the certificate authorities and the browsers have this thing called the CA Browser Forum where they get together and work out base policy for what is allowed to happen on the web PKI. What does it mean to revoke a certificate? When do you have to do it? What is the minimum that you have to do to make sure that either a normal certificate is issued to the right people or a extended validation certificate is issued to the right people? All of the rigmarole that is associated with setting these things up is decided at a policy level at the CA Browser Forum. But yeah, so there's a specification out on the internet right now. It says it expires in a month. There'll be an update, but it's out there at IETF, and it's being implemented by the first group is Let's Encrypt.
Whose DNS do you trust?
I'm sorry?
Whose DNS do you trust?
Oh, whose DNS do we trust? So that's a loaded question, because why would you ever trust DNS? Even with, I could go on for a long time about DNSSEC, but so the way all of this does come down to DNS, and to an extent, the registrars and their population of root domains. But the way Let's Encrypt handles validation is we go do the complete recursive algorithm, starting from the root for every domain, and then start at .com, and then go to the authoritative domain, or the authoritative name servers that are listed for the registered domain, and query those and follow whatever path. So we do not go to Google DNS, we do not go to OpenDNS, as much as we like those folks. This is both kind of a security thing, because it's better to go all the way to the source, and it's a lot harder to man in the middle all DNS records coming out of our data centers if you don't know where they're necessarily going. It's also a matter of like speed and efficiency for our clients, because often people screw up and have DNS records that point to the wrong place. And if we went to Google DNS, for example, we'd have to wait on them to expire their cache. When we do it directly, we can recurse ourselves and handle things a little bit more smoothly. And then the third is the least obvious one, and it's that even Google DNS strips weird things out of DNS sometimes, particularly things like the CAA records that we like, which are certificate authority authorization records that you can put into DNS. You can look up the spec. It's a cool way to say, for this website, only this CA should ever issue for it. It's like the ultimate whitelist. If you need to protect a bank or something, this is going to be a mandatory standard for the CA browser community, probably sometime in 2016, I'm told. And Let's Encrypt already supports it, and a number of other CAs also already check it. So, if you run a bank's website, DNS or something, you should totally go set a CAA record. It will dramatically reduce your exposure to people making, getting illegitimate certificates. for your site. Does that answer the DNS question? Yeah. Okay, we can talk about DNSSEC later if you like. Okay, cool. So the whole point of the standard is so that we can do automated validation. What the CA browser form says you have to do to issue a cert is validate that the owner actually controls the domain control. So automated validation has the additional benefit that you can go build a completely automated validation. Means you can go build tools into your process, whatever it is you happen to be doing in your ops group or in your security group. You can just go automate this stuff because no one should ever have to copy paste a CSR ever again in their lives. Just never, don't do it. Don't do it, it's terrible. It also lets you do other cool things down the line. Like, I really look forward to Acme, some version of it, just appearing in all the web servers and all of the load balancers and everything that I buy that I need to do TLS on. Like, I just want this stuff to work. I don't want to have to configure this anymore. Maybe set something in my DHCP config and they all just magically get certs. That would be awesome. So, it kind of takes, I lost my, my segue here, but anyway, it takes me to platform integration things. Not only can you simplify, I think, this deployment within your own sites, but out on the wild internet, a bunch of web hosts are starting to pick up Acme. That list is very abbreviated. DreamHost, Acme, and Wordpress are probably the biggest ones, along with Shopify, in terms of the number of domains that they've got out there. But the list of folks who keep contacting us and saying, we want to do free certs, like instantaneous when customer signs up, just keeps growing. The interest is getting really, really big. And there are even hardware devices. I have a Synology NAS at my house. I don't know if any of you heard of them. The next version of that, of their main software supports Let's Encrypt out of the box. So when you plug it into your house and set up the NAS thing, it'll just get a cert. That kind of stuff is just, it's just awesome. And the standard Acme protocol means that you don't have to use our software. In fact, a lot of folks have found that our software may not be good for their use case. It's one piece of software written for the maximum number of people possible, and it's not super flexible. There's a bunch of them. There's actually one written in pure Bash. Bash and curl. That's it. It's incredible. Like, I didn't know you could do this stuff in Bash. Like, it does JSON web keys. It's awesome. And I maintain a list. I'd be happy to tweet it afterward. We can talk about all of the weird clients. And there's some people are actually making lists of like top 10 Let's Encrypt clients. It's pretty cool. Down the line, I expect there to one day be a mod Acme for Apache, just like apt-get install mod Acme, and have it automatically handle encrypting everything for your, whatever domains you turn that on for. I've got a student as part of the Mozilla Winter of Security right now producing a patch for Nginx that does the same thing. Pretty sure that patch will not land in the main Nginx source tree because those guys are very peculiar about what goes into Nginx. But it's, a proof of concept that this sort of thing can happen. I've got a last bullet there, a web server that you've probably never heard of, Caddy server. It's written by a college student in Utah. It's actually super, super fast. It's written in Golang. It does HTTP2 out of the box. It's like super nice and stable. It has a very notable thing though. Because Acme is available for anyone to do whatever they want to with it, they have this, in Caddy server, this, they landed Let's Encrypt support in December into the main Caddy server. And the guy who, the author, made this video and posted it on YouTube without talking to us. He just did this all on his own, showing off how Caddy sets up a Let's Encrypt protected website. It's pretty short. It's 29 seconds. So let's go turn that off real quick. So did that start? Nope. There we go. So he's going to go download Caddy. Well, he's already downloaded Caddy, and then he starts writing a config file for a website, mat.life, which we already just saw. Then he launches Caddy server. It says activating privacy features, and then he goes, opens up Chrome, types in the website, and it's done. Let's encrypt. 27-second long demo, of which 4 seconds were getting the cert. There was no prior setup. It did the whole thing in that 4-second period. This whole website, this whole web server just handles it for you. You don't have to deal with this shit at all. It handles the renewals, it handles OCSP stapling, it sets it all up correctly. Like, this is the future. You should never have to worry about this shit ever again. So, let's encrypt in the wild. Well, this is the graph of unexpired certificates currently active from Let's Encrypt, and we had the general availability on December 3rd, so that's a little bit over 90 days ago. Let's Encrypt gives certs out that are 90 days lifespan, which is much less than you get from, 1 year from other certificate authorities. But the point is, you're supposed to automate this stuff and never worry about it again. Anyway, the little bump you see there is actually some of the first certs, roughly about 70,000 certs expiring that didn't need to be renewed because in the beginning people were issuing the same cert like 5 times over and over again. They probably didn't need 5 copies, but whatever. Anyway, the line just keeps going upward, and I was at the CA browser forum face-to-face a few weeks ago, talking with other certificate authorities. I was not there on behalf of Let's Encrypt, I was there as part of Mozilla, though everybody there knew I worked on Let's Encrypt, and that made for an interesting series of side conversations from other CAs. But one of the main things that people there were concerned about is, okay, Let's Encrypt, is it going to come through and just eat our business? And our argument the entire time, so that we've been doing this, 4 years, right, has been that Let's Encrypt is not there to go cannibalize the business of certificate authorities. There's 2 million websites on the public internet last year that had encryption, that had publicly trusted SSL, TLS. There's 750 million websites out there. We need to take those 2 numbers and make them the same, right? Or get as many websites encrypted as we can. And the hypothesis that we've had is that people would use Let's Encrypt to encrypt websites that have never had a cert before. Books that are businesses primarily that have a certificate from another CA, they're probably happy with that. They've already got a process in place. They like the insurance that comes along with it. They want an EV cert. They need it to be for 2 years or 3 years. Oh, that's fine. Like I said, our hypothesis has been we would be widening the market rather than eating people's lunch. And it turns out from our data, that's true. I did a bunch of analytics from Census.io and Certificate Transparency and tweeted this graph back in 19th of February, and it blew up. But the gist here is that over 90% of all websites encrypted with Let's Encrypt have never had a cert before. It's actually 93.9%, and that number actually is going up, not down. So that makes me super, super happy. As you can see there, that's a large number of domains. Something a lot of people keep asking me also, it's just one of those questions that's fun to ask. Okay, you've been at this for 3 months. How big is Let's Encrypt? And we issued our millionth cert this morning at about 3 a.m. local time. So that's 1 million certificates covering 2.4 million fully qualified unique domain names. And of course, there can be many FQDNs underneath a given registered domain. So that's 1 million certs for 1.1 million registered domains. Registered domain meaning something that you would go to a domain registrar, officially speaking, an ETLD plus the first label. So, and right now, as you see there, we, at 1.1 million certs, this is a little out of date, We are the fourth largest certificate authority in the world. On the public web, most of these certificate authorities actually issue a bunch of certs that don't get logged on the public web because they are going to companies' internal infrastructures. And that's not what we play in. But in terms of stuff on the web, which you can see. So this is only the beginning. Right now, the goal is to get every website using HTTPS. And this is a big goal, one that all the browsers are also interested in, because ultimately there's very little we can do to protect users of the web when the contents of their connections can be man-in-the-middle and changed. JavaScript can be inserted. People can change, even like the old-fashioned, well, my login page may be served over HTTP, but the form posts over HTTPS, which is, I guess it's a start, but then we just go edit that page on the wire and change the form to post the password somewhere else. And then, redirect it back to the HTTPS website. This is not good. We got to get the whole web encrypted. Otherwise, we can't protect people. And then we need to go get the rest of the web. People are actually already using Let's Encrypt for email servers, for chat servers, TeamSpeak, Mumble. It works fine for all these things, even though we didn't actually intend the certs that way. There are even some clients out, and whatever we intended, there are certs. Use them. Go protect yourselves. Go protect your users. And eventually, the Internet Security Research Group has this super wide, encompassing name. That's deliberate. Let's Encrypt is one thing. We're going to get this right, and we're going to go do more. We got the whole internet to protect. So we wanted to give, the big message to the world. The first cert we issued was for helloworld.let'sencrypt.org. And it was really, really cool to go and have that say, hey, verified by Let's Encrypt. So this is the part of the talk where I get to pop over to questions and answers. And yeah, please, I don't know how you like to do Q&A here. Should we queue people up or just
go ahead.
Okay?
So with free comes abuse. How are you going to maintain your reputation going forward?
Okay, so the question was, with free comes abuse, and how do we maintain our reputation? So here's the thing. Certificate authorities are in a shitty position to try to police the web. The design of the web PKI is that you, at some time, t=0, you validate that the person talking to you controlled the domain that they're requesting a certificate for. And that's it. You make this point in time observation that's a perfectly fine website, and this person has control. And then the certificate authority's job, whether you really believe this or not, is effectively done. Because even if you ask certificate authorities, if the person starts doing bad things, let's just say it's at time t=0, this was fine, but the website gets hacked, and then it's used for malware, or it's used for phishing. The certificate authority can go revoke the certificate, and nobody cares. No web browser checks revocations, because it's too effing slow. The only place where revocations get checked is extended validation certificates. And even there, all web browsers, in the event that they can't check revocation, they soft succeed, right? Because you don't want to give your users a bad browsing experience with oh, I'm sorry, we couldn't get this revocation status of this host. We're gonna not let you reach Gmail. OCSP is like I don't know if anyone in here works on OCSP. If so, you can come kick my ass later. OCSP is it's a very difficult protocol to get right, and CRLs are terrible. The revocation on the PKI, the public web PKI, is basically broken. So the ability for CAs to react effectively to bad actors is extremely limited. What we actually do in Firefox is we have, for sufficiently high profile websites, we have a block list called 1CRL that Firefox downloads every hour that has hashes of sites that are bad. And that is how we block known malware transmitting sites in Firefox. And Chrome has basically the same thing. Theirs is Site Shield, or no, Safe Browsing? Yeah, Google Safe Browsing. And Firefox pulls some safe browsing stuff, and IE Edge has a similar sort of thing. And the browsers have these mechanisms that move quickly. Like, they take at most 1 hour to update. Certificate authorities just don't have that ability. We made this, well, like it or not, that cert is good for 90 days, or it's good for 3 years. And since revocation doesn't work, as much as we try, the CAs are basically powerless to do anything of value on malware. So there are systems, as I said. I think personally that those are the right place to take care of malware and misuse of certificates, and not at the very, very slow certificate authority side. Follow-on question? No? Okay. Yeah. Okay, so the question was which browsers are using Let's Encrypt as a CA? So, all browsers pretty much. The way that works is becoming a certificate authority is hard. It takes a lot of time and it takes a lot of money to set one up. And the a lot of time aspect of it is actually because most browsers have what's called a root program that you have to go through various steps to get them to trust you as a certificate authority. You have to go through some audits. There are point-in-time ones and periodic recurring ones. You have to get all this paperwork. You have to buy all this equipment that meets all the audit requirements and so forth. And after you spend all that money and wait, do 12 or 16 months worth of work, then you can enter the 2-year queue to try to get into your first web browser. So knowing all of this, what we did with Let's Encrypt was, in that background between 2013 and the public announcement, and actually between 2011 and the public announcement in 2014, is we secured a cross-signature from one of the original sponsor companies, a certificate authority called Identrust. Identrust, believes in our mission, and they are already trusted in all the major browsers. Like, the only obvious place where they're not trusted is like game consoles, like PlayStation 3 and 4, and the Nintendo DS. So most things that people use to get on the web, they are already in there. And they signed Let's Encrypt certificates. And since the way public key infrastructures work is the trust flows down from the root, today, when you use a Let's Encrypt site, you go there in your browser, whatever it happens to be, whether it's Safari or whatever. The website presents a Let's Encrypt cert, which is issued by Let's Encrypt, which is issued, in this case, by Identrust. Let's Encrypt and Identrust itself up here is publicly trusted. Let's Encrypt is doing all the work to get into the web browsers. We've applied to all the major root programs and a bunch of the smaller ones like the Java root program and the Oracle Java root program, and a bunch of others, like 7 programs. I don't remember them all. I think there's a blog post about this. And the average wait time for this sort of thing is about 2 years. So the cross-signature from Identrust lasts way longer than we need it, and they're willing to stand by us until we're able to have trust all on our own, and then we just swap things out. Bonus side, again, with the whole Acme is totally automated. When the cert chains for Let's Encrypt are ready to change, because we're now trusted everywhere, you don't have to do anything. Assuming you use the protocol correctly, used a well-implemented client, all this stuff just fixes itself. You won't have to ever deal with taking your binary PEM files and concatenating them together into the right order and then launching the programs and having to say, sorry, I couldn't find the key. Oh shit, I put them in the wrong order. All that stuff. Don't do that anymore. All right, question in the back?
Do you have support, or is there any sort of project maybe doing integration with Active Directory certificate services?
So do we have any support, is question one, and is there any project to integrate with Active Directory certificate services, right? Okay, so starting with, is there support? Not the way you might think of it. We have a community website that's run, a Discus forum at community.let'sencrypt.org, where it's like help each other on support issues. And then we also, for bugs in the official client or bugs in the server, we have GitHub. You can open issues, and we're working on all of that stuff. We work with people every day. In terms of like, do you have a phone number you can call at 3 a.m. and say, oh God, my cert expired and I don't know what to do? No, we don't have anything like that. We believe we can automate this so much that you shouldn't need that sort of thing in the future. Go ahead with your follow-on, and then I'll get to the Active Directory part. Integration. Oh, myself. I'm sorry. Thank you. Okay, so then do we have integration support with things like Active Directory, I guess? All right, so not that I know of. This is kind of a fun one because last year I was part of Let's Encrypt's ops team. I was like the founding principal on that, though I'm not in there anymore. So if you want to hack my laptop and try to get to Let's Encrypt, you won't be able to. All permissions are gone. And I saw right from the get-go that we had a site running. Somebody in Redmond was building some sort of integration for Let's Encrypt, and was working on that for 3 months. I could just see all the requests coming in from a Microsoft IP address, and they had various user agents that implied that they were working on integrations there, but nothing has been announced. There are a couple, there's like an integration for IIS that somebody put together. I don't know how good it is. And there's also like a PowerShell integration that I understand is pretty good. As far as like integrations with Active Directory itself, I'm not sure what you're thinking of there. Let's Encrypt only issues certificates for websites, and while you could theoretically, you can get a cert for like a router or something, but there's nothing currently that I know of that would do that. That said, given how powerful PowerShell is, and that there's a really good C# client for Let's Encrypt or for Acme already, I imagine this is something like you just need to go hack on it for a weekend and you can probably put this together. So, pull requests welcome. Okay, so.
Do you have any support for WordPress yet?
Yeah, so WordPress.com rolled out Let's Encrypt last month. They issued like a ungodly number of certs in like a 12-hour period. It was pretty cool. And then there are Let's Encrypt, there's like 2 or 3 Let's Encrypt plugins for WordPress if you have your own. I don't know how easily they work because WordPress doesn't typically have access to configure the web server, but I think they help you along with like, okay, here's the copy-paste file to drop into the web servers, like here's the private key or whatever. I'm not sure exactly how they work there. On that note, there's actually a really cool website done by somebody else in the community who I actually have no idea who he is. I've never seen his real name, but it's like ssl4free.com. It's a JavaScript implementation of Acme, pure JavaScript, and it like walks you through from, it runs entirely client-side. Okay, just you can like save this JavaScript to your desktop and just open this thing offline and it'll do everything. But it like walks you through what domains do you want to get a certificate for, and then it gives you a command to copy paste and run on the server that calls OpenSSL to produce the correct private keys. and then it says, okay, now copy paste this output that contains the CSR into this field to hit the next button. And then it gives you another thing to copy paste with OpenSSL commands to sign stuff. It's really fascinating. You have to end up doing that every 90 days, of course. So it's not like a perfect automation solution, but like you can do these clients in Bash, you can do them in JavaScript, you can do all kinds of sorts of things to fit this into whatever your use case might be in the meantime until you go and automate the heck out of it. So I got a couple of other prompts, like I know a lot about Let's Encrypt's operations. If you're curious, like how that all works or how we set the thing up. We posted a blog post some time ago about some general things, but I can answer more specific questions or rehash that if you're interested. Or I know a whole lot about the Web PKI. I also know a lot about CA Browser Forum and the Internet Engineering Task Force, and I just got involved in the World Wide Web Consortium. Happy to field questions on those things.
Can you talk about browser certificate pinning and the future of, from a security perspective, we're losing all this kind of visibility when we encrypt everything? How we're going to man the middle traffic to do inspection? All right,
that's a loaded question. Good job. Okay, so talk a little bit about HPKP, HTTP public key pinning, and browser security and how we do inspection in the future. All right?
Yeah.
Okay. Okay, so HPKP, if you're not familiar, is a header that you can add into a HTTP response that says, "Dear browser, you have reached my website. When you come back in the future, you should expect to receive a public key somewhere in the chain that matches this, or this, or this, or this." You can have a bunch of these. If you do not see this public key, then somebody is futzing with you, and you should, no matter what the rest of the certificate chain says, you should abort and tell the user there's badness. The idea here is, in the event that somebody produces a man-in-the-middle certificate for a website, when you set up HPKP, you tell the browser, even if you see an otherwise good cert, if it doesn't have this in it, it's not good. And the browsers are supposed to persist this for a timeout. You can set that to whatever you like. SSL Labs gives you like mega bonus points for setting this really high, which is kind of a dangerous thing to do in the event that you change keys. And there's a bunch of different guidance about how to do this. As a note for anybody interested, it is public key pinning, it is not certificate pinning, so technically you don't have, when you get a new cert, you do not have to change keys, so you can make this fairly robust if you want to. But it has this downside if you are interested in observing user traffic, where if a site pins and you have a man-in-the-middle box from, you know, F5 or whoever, SonicWall, whatever you happen to have, the user's web browser is going to say, hey, I just got a perfectly valid cert that is signed by a trusted root certificate authority, the corporation's man-in-the-middle box that got installed by the enterprise control. However, it did not come with one of these public keys that I was told to pin. So abort, we're done. Tell the user you're being man-in-the-middle, and they go freak out. So this is awesome for users, and it's not necessarily awesome for those of us who might need to inspect connections, look for badness. So this really affects mobile use cases because, like, the folks that I know who do this on like desktops, who have an enterprise root, just have a policy in place that when they are man-in-the-middling the connection the first time, they strip HPKP headers, so this never comes up. But all honesty, this is a place where the security of an enterprise is sort of orthogonal to the security of the individual user. And I think the right thing to do here is to set prefs. Like in Firefox, there's an about config item to go turn HPKP on or off overall. And for most people that are deploying Firefox in an enterprise environment, you're having to do finagling anyway to go and insert a man-in-the-middle root CA. So you might as well just flip that pref and just say, inside my network, the man-in-the-middle box, or the enterprise inspection box, sorry, The enterprise inspection box is responsible for making sure that the users are secure and connecting to the right websites. We don't need to delegate this to the browser, so let's just turn that off. Chrome has a setting for this too. So I think if you're in a network where you control the inboxes, that's just what you got to do. And in the bigger picture, my opinion here, right? I'm not speaking for Mozilla, but my opinion is in the bigger picture, while this requires you to do more work on an enterprise network, this is really critical for people who are going to coffee shops and connecting to the first unprotected wireless network, who might, have an unknown installed extra root from their antivirus vendor, who shall remain nameless, that we shamed back in December, or any of the other ones that happen to be out there. And there's real danger, If they can go man in the middle of their bank connections, this is bad. I think enterprise users, you're out there to take care of them. We need to do our job to protect, my mom. Follow-on questions about that? HPKP, how to use it? Enterprise? No?
So, if we're going for total encryption as the end goal here, and to protect people from unprotected networks or questionable environments, how would you go about as opposed to going through and stripping out the functionality for the public key, as you just mentioned, and doing a man in the middle or some type of protection system like that? Has there been any work in setting up a host-based IDS of some sort for just the browsers themselves? So you can gather that information from the browsers as opposed to sending it off the network, or has there been any talk about that?
It's interesting. I encountered that idea about 8 or 9 years ago about putting a plugin in a browser that would be an IDS. I haven't actually heard it anytime recently, and I'd totally forgotten about that. So the question was, given the goal of HTTPS everywhere and just encrypting all the network connections, given that the transport layer is not going to be a good place, or not going to be an easy place to make sure that users' browsers are doing the right thing and that users are not doing the wrong thing, has there been any thought to, instead of trying to tap the COM layer, tap the application itself to go and evaluate risks and such? Is that the gist of it? Okay. So basically doing host per host or per browser IDS type functionality. I haven't heard about this myself, but certain antivirus programs, like I know there's like Web Defender from Kaspersky Labs that does this sort of thing poorly. I mean, not poorly. I won't judge Kaspersky's products in front of everybody. There are certain products out there that do this thing a little bit. I don't know of anyone working towards this in any big fashion, but to be completely honest, it's the thing that comes to mind to me as well that we should do in the future or even in the present to protect these things now going forward. I think there's too much at risk in mass surveillance, dragnet surveillance, to continue to do it on the wire. But we already install antivirus for all of its 50% success rates. I think it makes a lot more sense to go do this sort of analysis in more virtual machines or more sandboxes that protect users.
Well, there's been an increase in threat feeds such as Taxi and a lot of the other technologies, which you have a constant incoming feed of known threat actors. Mm-hmm. And allowing a browser to take part in that and at least tell the person that, hey, there's a question going on. I know that Microsoft has something built into their browser which does about the same thing. You said that there's a feature in Let's Encrypt, which kind of, or at least in Firefox, where it goes out and checks certificates validity to a certain extent.
Yeah, so the clarification was that there's, like IE has their, I think it's called Safe Defender, list that they push to browsers. It's actually fetched by browsers, again, about every hour, that has information about known bad actors. And Google has safe browsing and a additional like badness list that they send to Chrome. And I think they're faster. I think they do it every 30 minutes. Firefox has one CRL, which started off as just these are certs that are revoked, but we've actually just in Firefox 44 we changed it to be a very generic structure, and we intend to be able to put a lot more threat modeling data to alert people that things being bad. We just haven't done it. I think, yeah, that this is a place where browsers are going to have to pick up the slack, and I don't know if it's going to be the browser themselves or this is going to be the evolution of the antivirus market. But there's clearly a need. It's just, there's clearly a need, and I think there's room for that.
I had a question about the HTTP. For those of us who test web applications for a living, it can be a little bit of a hindrance. So, do you see any improvements in the protocol happening so that somebody can opt into allowing like a second certificate being accepted or something like that?
Okay, so the question is, for HPKP, HTTP public key pinning, is there room in the future movement in the protocol to make it easier to do security engineering work like pen testing and so forth that currently becomes a real pain in the ass when you turn on HPKP? Not speaking as Mozilla here, speaking as JC, HPKP, the IETF made some serious errors in stating it. Like the main one that's missing that's better in like content security policies is that there's no notify option. Like with CSP, you can say report only. Turn that on, and web browsers are supposed to, if they hit a failure, supposed to report it, but soft continue, like continue anyway, and just let people know what's going on. HPKP has no such thing, and it makes it a real pain in the ass to turn on for websites because you have to go on and then users hit it, and if you screwed up, they are locked out of your website for 3 months or whatever. It's brutal. I don't know what we can... Firefox doesn't like changing, modifying web standards. Like this is the old school, like, we are the champions of the open web. We think what all should be done open. And unfortunately, HPKP is a published standard at this point, and we need to like fix it at we feel like we need to fix it at the IETF, but we've been pressured into fixing these things from other browser vendors from time to time. When I do pen testing and run into this, the fix is always to open a new profile because all the stuff gets saved per profile in whatever browser you're using. But of course, I'm kind of a power user and know what that means. And technically, since it's an HTTP header, you can also configure your web server to only emit it to certain clients,
right.
Which is also a kind of fun hack to go really screw with people if you want to.
Sure.
I don't know, your website just suddenly doesn't load at all in IE. I don't know what's going wrong.
In cases where you're looking at a thin client using it, or a thick client rather than using it, you have limited control, except for just messing with the headers that are responding, and if they're doing hard checking, you basically have to recompile the thick client or modify the bytecode or whatever. But,
yes. Yeah, so HPKP, as amazing as the idea is at preventing people from sniffing traffic on open wireless points and so forth, in practice, it falls flat in a lot of places. So, we don't turn on HPKP for any Mozilla property at this point. We have a pinning list inside of Firefox, which is the same idea, but we have more control. I don't turn on HPKP for any of my websites either. There are good, I can point you to some good folks who have really great descriptions of how to use it well, but even that is pointed at end users and not at like folks trying to do work on apps for a living. It's going to get fixed. It's like too important of a concept to sit as it currently is, but it only became a web standard or a IETF standard last summer. So IETF doesn't move super fast, and the working group unfortunately was done. So now it has to be reconstituted, and that will probably happen. I'm guessing that may happen in Argentina in next month. So maybe we'll start to hear something about it. Absolutely. I threw up another note about, I can talk about HTTPS everywhere. I'm not from the Electronic Frontier Foundation, but I love those guys, and I can talk a little bit about that sort of thing.
Please tell me about that.
Okay. So that's HTTPS Everywhere is a initiative to go convince part one is set up browsers so that if a website can be accessed securely, to force it to be accessed securely. It's the same sort of thing as turning on HTST, or HSTS rather. I always screw that up. HTTP Secure Transport, or HTTP Strict Transport Security, thank you. But for websites that you've never seen before, because when you put these things in headers, you have to go to the website before you get the pinning header, or go there before you get the HSTS. There's a plugin for every major browser that EFF publishes that just has this like meta list of thousands and thousands of websites that if you do go there, it should be HTTPS so that you don't get man in the middle the first time you go there. They also are involved in doing scans of the internet through scans.io and the University of Michigan ZMAP project, looking for places where there should be HTTPS and there isn't. And when they can, when there's free time, they contact folks and try to convince them that this is not good for their customers, this is not good for the web, go do the right thing. And it's a bunch of advocacy. I guess when I say I know a lot about HTTPS everywhere, it's more like a general concept than necessarily like a whole depth of the EFF's process. But
have they found stuff that should be available via HTTPS everywhere? In other words, the STS, but from a different view, it doesn't meet the same guidelines. It doesn't. They don't get the same pinning.
So has the SSL Observatory, the distributed SSL Observatory, and things like scans found places where HTTPS should be used, but it's not in use because of how they're looking at the network, the position at which they're observing? The answer is yes, but again, this mostly happens in the developing world. It's super common to force well, maybe not. It's not uncommon to have carriers deliberately kill the like black hole the packets that set up TLS because they just don't want you to do it. So then they can't serve ads, they can't change things. We're in a luxurious place here in the United States where for the most part ISPs get their ass handed to them when they do that sort of thing. Maybe not immediately, but eventually justice comes around. But it's a much more Wild West in a lot of other places in Africa and in particularly Southern Asia. So yeah, it does happen, and there's very few people that run, as I understand it, very few people run the distributed SSL Observatory plugin in Firefox and Chrome in like Asia, but the people who do, it just like triggers constantly. So it must be really hard to try to do secure life there.
Thank you.
Yeah, absolutely. Any other questions? Cool. So I'll hang around. Feel free to come up and introduce yourself. Again, my name is JC. I work for Mozilla, but I spent more than a year working on Let's Encrypt. and I'm super proud of it. Happy to talk about ops, DevOps, Golang, crypto, and thank you very much for inviting me.